I'm presenting on behalf of the Utrecht NMR group. I'm a remote NMR user. The remote NMR setup has been made by our facility staff, Andrei Gurinov and Johan van der Zwan. The motto of our facility to study biomolecules in vitro, in situ, and in silico. Utrecht University, we have 10 NMR machines from 400 to 1.2 megahertz to do a solution NMR, solid state NMR, and cellular NMR. These are all the people involved. This 1.2 NMR instrument is not property of UU itself, the Utrecht University. It's actually funded by a consortium of the main Dutch NMR sites. It's Leiden, Nijmegen, Wageningen, and Utrecht together with medical centers. So the machine is hosted in the Utrecht site, but it's open for all the Dutch NMR groups. So we do also quite a bit of facility work for Instruct and for iNext discovery projects. And of course, yeah, we have also a remote NMR setup. So I'll share our initial experiences with TeamViewer and then the two alternatives that we have set up either via just VNC and SSH, somewhat similar as Trent just presented, and via a VPN. And to conclude, I'll show you the remote magnet system, monitoring system that Johan and Andrei set up together. So initially we used TeamViewer, which was absolutely great until we indeed got kicked out because we didn't pay for a license. Yeah, the right to free license is really only personal use, and if you log in multiple times, you will simply get blocked. The advantages are that it's really a very high quality of remote access, so the display quality is very good. It's very fluent with keyboard and mouse control across cross-platform use, and also the nice thing is that you can connect from anywhere as long as you know the password. Doesn't matter where you're at home or in the train or traveling or anywhere. But we had to find another solution, and the solution was the first one was developed, set up by Johan, and it's just to use VNC via secure shell tunnel, SSH tunnel. So we have our spectrometers behind the firewall on the university. We have a local server that can connect to all the spectrometers. And what we need for the user is to be able to access this local server via SSH. Now, this works actually very well, and it's for free, and it will work as long as the university IT department will allow us to connect via open SSH port. This works actually with good quality, maybe a little bit less than TeamViewer, but it's really quite fluent. There's no delay in controlling the spectrometer. You can use the setup with any VNC client, whether it's I don't know what, so it's also cross-platform. And because we administer the local server, or actually Johan does, he has complete control over who is allowed to connect to the spectrometers, yes or no. Now, the disadvantages of this setup is that we're actually limited to an old and outdated VNC server on the spectrometer that limits performance a bit. So one of the quirks that I experience is that sometimes key just hangs. So you want to press 1 Z for ZG, and then all of a sudden you have 100 sets on the screen. So the quality is a little bit less than TeamViewer. And of course, there's a bit more manual setup involved. So we have spectrometers that all run Linux operating system on their controlling computer. And from what I understand, because of Topspin, this is limited to CentOS 7, which is an older version of CentOS. And that means that the VNC server, so that's actually the Steiger VNC user that Trent just mentioned, also known as the X0 VNC server, that's the only one that we can use. It is a bit older one. So the spectrometers can all connect via SSH to this local server. And Johan made a setup on each of these spectrometers to define a specific port for the VNC traffic. Then what he also did, and which was actually very useful, is he made a script to check whether this VNC server is still running every 50 minutes, because there is a tendency, or it can happen, that the server crashes, and then you would have no remote control anymore. So every 50 minutes this is checked, and if it's no longer running, the VNC server is automatically restarted. So on the, that's what I already mentioned. So on the local server, we have a situation that the user can only SSH into this server, and the outgoing traffic can be anything. So that can be the whole display of the spectrometer. For the moment, this is allowed by the university, but our university has expressed also a desire to crack down on all this simple SSH access, and they may in the future enforce that there is some kind of two-factor authentication on a controlled local server from the university IT. This server that we have now is our own, but this may change in the future. So for the moment, Johan is controlling this. He can define exactly, or he will make he made accounts for the remote user and allow only traffic for one IP address to further secure things. So I can only connect from home and not while I'm traveling, for instance. So as the user, the only thing that you need is SSH and a VNC client. And to set up the connection, you then need to create this tunnel, and that's a long command, but it's actually also not that complicated. So with the SSH program, you can define a jump host that is this local server where you have a specific user account, and then you can define this port forwarding that from a certain port on your local computer, you can connect to the VNC port that's defined on your spectrometer. And then you can, the last part is the ultimate destination is just the IP address of the spectrometer. Now, you don't want to type this all the time, so you can define in your Unix, Linux environment some kind of alias to tunnel to, for instance, to the 600 or which other spectrometer. These port numbers that can be defined by the administration to set up in any kind of way. So that's not a specific number. And then you can use any VNC client to connect to this local port number. So how does that work in practice? So I would open up a terminal, then, oops, yes. Oh, sorry, once. Was a little bit too quick, sorry for that. Yeah, open up terminal. So then I would type tunnel 900, that's my macro to enter the 900 spectrometer. So this first is the jump to the local server, so I have to type my password to the local server. And then this would be the login to the spectrometer itself with the spectrometer password, and then you are inside the computer. Then, of course, you want to start your VNC connection. Does this work? Maybe I have to press. Sorry. Yeah, so the macOS has this screen sharing app. That's the built-in VNC client. I connect to the VNC port of the that I've defined in this tunnel command, and then you're essentially have the same kind of view as in TeamViewer, but then through this built-in VNC client of macOS. So you can see that you can navigate quite easily. This is then an experiment that is running. We can process the data. scroll up and down, look at the noise, do some phasing. The phasing is always a little bit an issue with the remote control, in the sense that the mouse sort of overreacts to your movements. So it's best to actually just press the button 0 for the zero order correction, and then use the scroll wheel to fine tune the phasing. But this works all quite well. Then another thing that I've done is made a set of macros to create a data set to help remote users. So you would enter your initial, some kind of acronym, and it also prompts you to specify the metadata for your sample. And what you then get is a data set with a consistent naming, and that also has inside the title field the information on your sample. It also has the information on what to do and how to use the spectrometer for pulse calibration, and it provides some step-by-step instructions on what to do, how to record the 1D, how to record the 2Ds, etc. And in that way, I sort of can also offload a lot of explanations and time directly to the user. And so in most cases, just as simple as just changing your proton pulse length, and then this is all good to go. Maybe adjusting your spectral widths and so on, and depending on your needs. So yeah, I think that's the end of this demonstration. You can still get a feeling for the smoothness of the control. So the other way that that Andre developed is to use a virtual private network, a VPN server, and this works also very well. At least for him, I didn't get it to work yet, and this is also a free solution. So the way that this works, or well, the advantage actually of this is that this is completely outside of the control of the university, at least for now. And we use the zero-tier VPN server to mediate a secure direct connection from the user PC to the spectrometer, a little bit in the way that TeamViewer also does probably. So you get a direct connection from your computer to the spectrometer. That also means that you can connect from anywhere, also when you're somewhere else on a conference. And the performance of this connection should be a little bit higher than the SSH tunnel that I just showed you. So it does involve some setup. So you have to, again, have this X0 VNC server on your spectrometers, define a network interface on each spectrometer for the VPN. Then on the zero-tier, you can set up for free your own VPN server and add the spectrometers to this VPN and add the user device. Even mobile phone can work, or an iPad, or your laptop to the VPN. And then all these machines that are inside the VPN can talk to each other. So the user has to install the zero-tier app, also cross-platform, also for free. And then you can connect to this VPN server, and from there you can again use any VNC client to get access to the display of the spectrometer. So the disadvantage of this setup is that the free mode of using this VPN server is limited to 25 devices in the VPN network. Of course, you can pay a fee to get a larger network. The manual setup is a bit more involved, perhaps, but as a user, it's actually very easy because you don't need to bother with this very complicated SSH command. You can just connect directly. Again, one disadvantage is that we are still stuck with this X0 VNC server, which is kind of old and outdated and can crash. So who has been using remote NMR so far? Actually, it is only the local staff and local users, so the PhDs and the postdocs. There's one or two external users that are still able to connect via TeamViewer, so they can still use that for connections, but we didn't use it for external users And there's a couple of reasons to do that. Of course, one is just the burden of creating and administering the IP addresses, revoking their access after use. But there's also clearly a benefit of physical visits in the sense that it can reduce our own workload, especially if there's users with that require sample manipulations, titrations, and other things, and that's you ideally like to leave the responsibility of these sample manipulations with the user. Also found that for early, like say for PhD students that want to visit, it's actually a benefit for them to come in terms of their learning experience. They also really like to be there and sit behind the machine and get this direct feedback also from us. Then if you're dealing with non-NMR people, so in terms of, for instance, INEX discovery, if these people are really molecular biologists or biochemists, they actually just want to get the data, so they're fine and happy by using us as a mail-in service facility, and do not necessarily want to be involved with the data collection. And the final point is that we also just addressed in that Trent addressed in his talk is the trust issue, right? Of course, also when a physical user comes, you have to trust them to not screw things up. But with a remote usage, there is an additional psychological change by being remote. And if in our current setup, if you are connected remotely, you have total control over the machine. You have access to all the data, also of other people. We all have the same passwords and usernames probably on spectrometer, so you can very easily also change topspin administrator level settings. And as soon as you can open a terminal, you can access any other computer on the network as well. So of course, that is a problem of this current setup. So then the last thing that I wanted to show you is what Johan and Andre developed to monitor our magnets remotely. Initially, they developed simply screenshots posted on the web server, but it was a public web server, so there was some issue with security and privacy there. We recently had also a helium recovery system of quantum technology installed that also required more monitoring. So they've spent time to set up just a bunch of scripts to collect all the information from all the magnets and store it on a web server where they can monitor everything that happens to the system. So for instance, you get a plot like this showing all the helium levels inside the magnets. These are all these lines, and the helium levels. Let me check again. Yeah, the blue line here is the helium level in the recovery system. This is in the magnets, and this is the total. And this shows you over the last 6 months what is happening. And this allows, of course, to really monitor the performance of the system and spot any leaks, and also to plan when to fill the machines. There's really a very detailed overview that can be got from this system, so we can see the helium level in all the magnets and also the performance of the recovery system in really great detail. So to conclude, yeah, we invested in some cheap or free and good quality alternatives to the TeamViewer solution. Still, this is not a very not the best solution, because yeah, we need something with controlled privileges, both on the spectrometer side and both within Topspin. There's still a hanging issue of university IT policies. Right now we're sort of operating on a don't ask, don't tell basis. But if they want to crack down on all these kinds of access, they can, of course, and that would have serious consequences. And then I showed you some setup tools that help to shift agency to the user, which is also important in this remote setup. So to help with metadata tracking, consistent naming, and loading default experiments that have verified acquisition and processing parameters and provide some on-screen instructions on how to use these experiments. And I showed you this helium recovery monitoring system to aid problem detection and planning. So with that, I'd like to thank especially Johan here and Andre, who set up these things. Thank you.